So what about if our inequalities are a little bit more complicated? What if we have rational inequalities? That's what we're going to talk about here. So let's look at this first question. X minus 2 is less than 8 over x. How can we solve this? Let's start off by thinking about how we would solve it if it's a regular equation. So x minus 2 is less than 8 over x. Sorry, and I'm going to change that, my bad, change that to an equal sign, right? Let's pretend it's an equation instead of an inequality. How can we solve this? Well, my way to solve it would just be I would multiply both sides by x or cross multiply by x, either way. So I would end up getting, if I multiply both sides by x, x squared minus 2x equals 8. And then I could solve it, x squared minus 2x minus 8 equals 0, set it to 0, and solve, right? That would be my way of doing it by that. So I would factor it and so forth, find the solutions. Now, this actually doesn't work exactly like this for inequalities. And I want you to think about why. Pause the video, think about why. See if you can figure why this strategy won't work. So the answer is really in this first step where we multiplied both sides by x. That's what I did here to get this second line, right? I just multiplied both sides of the equation by x. The problem is, do we know if x is positive or negative? We don't, right? X could be positive, it could be negative, it could be 0. We don't know, right? The problem is when we multiply an inequality by a negative number, it's going to flip the sign, right? So sometimes the sign's going to be flipped if x is less than 0, and sometimes it's going to stay the same if x is greater than 0. So we don't know. So we actually take generally a different approach when solving these polynomial, these rational inequalities than we would from just solving the equation. And this is how we do it. We're going to move that 8 over x to the other side. X minus 2 minus 8 over x is less than 0. Have we broken any of those rules yet? No, we haven't. We haven't changed. There's no way that sign is going to flip because we haven't multiplied or divided by a negative number, right? Now, let's turn everything on the left side into a fraction, right? Into one fraction. So we find the lowest common denominator is going to be x, right? So I'm going to multiply each term. I'm going to multiply this term by x over x. I'm going to multiply this term by x over x. And then that should give me a simplified expression. Maybe not simpler. So it's going to be x squared minus 2x minus 8 over x is less than 0. So look what we have now. We have a rational function all on one side, and we haven't broken that rule that we would have broken here where we can multiply by a positive or negative number. We're not sure if it's positive or negative, right? We haven't had to take that into account when we did it this way. So that's why we usually just avoid this when we're solving questions like this. We avoid multiplying both sides by any factor, okay? So we can solve it now. Now we can solve it like any other polynomial. So I'm going to factor what's in the top. So the answer is x minus, I think, 4, x plus 2 over x is less than 0. So think about what we did in the last section where we solved polynomial inequalities. In order to find out where this was true, we looked at the different solutions, our critical points, right? So we know we're going to have to look at 4 and 2. So looking at the solutions to this, we can sort of say that the solution is going to be x minus 4 has to be less than 0, in which case, just zooming out there, x has to be less than 4, or x plus 2 has got to be less than 0, in which case x has got to be less than negative 2. The other thing, what else do we need to consider though? Where else does something weird happen in this function? And the answer is in the denominator, right? Because the denominator tells us that x cannot equal 0. So we actually have 3 critical points for this function. So in order to find out where this is true, where this thing is less than 0, we can set up our table, right? And we did, it's a similar way to how we did it the other time. So our critical points, I like to write out the critical points first. So our critical points in order are going to be negative 2, 4, sorry, 0 comes next, right? Not 4, 0, and 4, right? Set up the table. So between negative 2 and 0, we could say negative 2, less than x less than 0, and 0 is between, or sorry, x is between 0 and 4. And then we also have our ranges on the outside, right? So if x is less than -2, and if x is greater than 4. Let's put another line there. And then on the left side of this, we're going to put our factors. So the factors here are going to be, what is it? X minus 4, x plus 2, and x. Right? Those are our three factors. They're going to determine whether this thing is, or where this thing is positive or negative. If you want, you can just plug in numbers, test values into the original function, but this just breaks it up, makes it a little bit easier. So less than -2, I'm going to plug in, I don't know, let's try -3. Between -2 and 0, that's -1. Between 0 and 4 is 1. Greater than 4 is 5. Okay? So if I plug in -3, this thing is going to be negative, this thing is going to be negative, this thing is going to be negative. If I plug in -1, this is going to be negative, this is going to be positive, this is going to be negative. If I plug in 1, and we can continue here, this is going to be negative, positive, positive, and 5, positive, positive, positive. So that tells us these three negatives, negative times a negative times a negative, is going to give us a negative. Negative times a positive times a negative is going to give us a positive. It's going to be negative, this is going to be a positive. So it tells us that our function should be less than 0. Remember, that's what we're looking for, the ranges that are less than 0, when x is less than -2. That's one of the ranges that's true. And then also when x is between 0 and 4. So those are the two ranges that satisfy our equation. So we could write out our final answer as x is an element of real numbers. If we want to write in set notation, x is an element of real numbers such that x has got to be less than -2 or between 0 and 4. Keep in mind here, this is a less than sign, not a less than or equal to sign, because the sign here in the original question was just a less than sign. So just to clarify, this notation for our final answer is called set notation. We can also represent our answer on a number line, right? Which is another convenient way to sometimes write our answers. So our critical values here on this are -2, 0, and 4. So that's really all we need to include on our number line. I'm not picky about that, about making it to scale or anything. So we say our answer is when x is less than -2. So less than -2 means over here. And are we going to put an open or a closed dot? Well, because it's just less than, it's not less than or equal to, it's an open dot. And then our other solutions between 0 and 4, not including 0 and 4, right? So we need an open dot at 0, open dot at 4, and it includes this answer here. So that's just another way to answer, to state our final answer for the question, is just a number line like that. Now to get a better sense of what's actually happening here, let's go to Desmos and plug this in and see what we get. So here are the graphs of x minus 2 and 8 over x. X minus 2 is obviously the line, the red line, and 8 over x is the blue rational function. So the inequality asks us where x minus 2 is less than 8 over x. So if we think about it, that's asking where the red line is less than the blue line, right? Or is lower than the blue line, essentially, right? So what we need to look at is where the red line is below the blue line. So up here, sort of to the right of 4, the red line is on top, right? But as we cross 4, now the red line is on the bottom. So this part would be included in our solution, right? From 0 to 4. And we see that in our answer here, right? If we go on the other side of the asymptote, right, the red line is now on top, right? So that's not part of our solution because the red function is higher or greater than the blue function. But then as we pass -2, the red line is back on the bottom, so that is part of the solution, right? Just as we see when we look at the answer, right? X is less than -2. So that's our solution. We can throw the inequality into Desmos to check if we're correct, and can do that just by clicking on that right there. So now we see the green shaded region represents that. And if we look over here on our right, we can see that that's the same thing as we showed on our number line, right? From 0 to 4, right? That green area is shaded in, and less than -2, that area is also shaded in. Now, the last thing I want to do before moving on to the next question is look at what happens if we make this mistake. So remember here, the first way we tried the question is just by cross multiplying and simplifying. And we came up with this equation here, right? So if we wrote that as an inequality, it would be x squared minus 2x minus 8 is less than 0, right? Where is that true? So I decided just to throw that into Desmos as well. Let me hide the other one actually. So let me turn off all the other ones. And if we activate this one, the solution to this inequality just says that it exists between -2 and 4, right? We know that's not the actual answer. There's an asymptote here at 0 that messes everything up, right? And we know the function actually does exist, or is true, I should say, the inequality is true to the left of -2. So this, by getting rid of that, or by multiplying both sides, I should say, by that x, we actually remove some solutions and we actually end up getting the wrong answer. So again, that is not the way to solve these problems. So on to the next question. This question has us solving this inequality, right? And it looks like two rational functions. Now I know it's really tempting to cross multiply and simplify, but we saw in the last example that that doesn't work. That actually will give us a wrong answer, or it'll basically remove some of the complexity from the answer and give us the wrong answer. So instead, we got to move everything to one side, turn it all into one fraction, and then simplify. So pause the video here, try that yourself. When you're done, unpause and you can see the answer. So here we go. After you've brought everything to one side, collected it into one fraction, and simplified, you get this. Notice how I also managed to factor the top of it just to make it a little bit easier to do the calculations later. I also left the bottom factored. I didn't need to do anything because that's easier, way easier to find the asymptotes, right? So anyways, what are the solutions to this problem going to be? Well, we know 3x plus 5 has got to be greater than or equal to 0, right? So that means that x is got to be greater than or equal to, if we bring that 5 to the other side, divide by 3, -5/3, right? I'm also just going to write it as an approximate decimal, a -1.67, just to make our math a little bit easier when we do our ranges, right? That's not the only thing to consider, though, that 0 or that x-intercept. We should also consider where x cannot, what x cannot equal, right? And we get that from our denominator. So our denominator tells us that x cannot equal -1 or -4, right? Those are basically going to be asymptotes to this equation. So next step, we have our 3 critical points, right? Now we need to set up a table in order to find out where this is true, where this function is actually less than or equal to 0. So pause the video here, see if you can set up your own table, and then you can unpause to see what mine looks like. So here's the table I set up. X is less than -4, x is between -4 and -1.67, x is between -1.67 and -1, and x is greater than -1. So now let's plug in some values into each of these ranges to tell us what each of the factors gives us, a positive or negative number. So less than -4, let's plug in -5. If I do that, this is going to be negative. The second factor is also going to be negative, and the third factor will also be negative. 3 negatives make a negative. Next one, between -4 and -1.67, -2 is an easy one to plug in there. -2 is going to make this one negative, and this one positive. So this will actually be positive. Between -1.67 and -1, let's do -1.5. This one's a little bit more tricky here. If I plug in -1.5 into that first one, I'm going to end up with -4.5 plus 5, which is a positive number. The second one, I'm going to end up with a negative number, and this I'm going to end up with a positive number. So my answer is going to be negative. And then lastly, let's plug in 0, because that's greater than -1. And if I do that, I'm going to get a positive, positive, and positive. So that segment is also positive. So what is the solution to this problem? Remember, we're looking for, if we go back to the problem here, or back to our simplified equation, we're looking for where this thing is greater than or equal to 0. So where is this function greater or equal to 0? And we can see, if I take out my highlighter here, greater than 0 Well, that's where the function is going to be positive, right? So that's going to be this region here. That satisfies the condition. And also this region here. That satisfies the condition. So if we had to write out our solution to this problem, in set notation, oops, I should use a pen. In set notation, I would do x is an element of real numbers such that x is between -4 and -1.67, and also x is greater than -1. Do you see any issues with this? Well, let's look for a second at our problem again. The problem said where this function here is greater than or equal to 0. So the question is, do I put in the less than or equal to signs here? Well, we can ask ourselves, which one of these makes the function equal to 0? Which one of these critical values? So which one of these values essentially can the function be equal to 0? And if we go back to what we actually found, we found that 3x minus 5 or plus 5 is greater than or equal to 0. X has to be greater than or equal to -5/3, right? So it's allowed to be equal to -5/3. And remember, we just simplified -5/3 as -1.67. So it's allowed to be less than or equal to -1.67. Is that true of the other ones? Should I put it here and here as well? Well, is the function allowed to be equal to -4? And again, if we look back at what our function said, that was also an asymptote. So x cannot equal -1 or 4. So that tells us the function here and here actually can't have the little equal sign, right? Because the function is not allowed to equal -4 or not allowed to equal 1. But this one, it makes sense because the -1.67 was a solution. X is greater than or equal to -5/3. So there we go. That is our solution. You feel free to check your own answer in Desmos to see if it's correct. Before we do this last problem, have a look down here at this general pattern to solve rational inequalities. So generally, we set the inequality to 0 and combine terms to create one fraction. We know that. Then we factor to determine zeros and discontinuities. Check each interval. Those are the critical values you check, the zeros and the discontinuities. And then state the solutions for the valid intervals. So we basically make the table to do that. So this question here, example 3, has us solving this inequality. Now, think about what this inequality actually is asking for. It's asking for where this function is greater than or equal to 0. What type of function is this? It's a rational function, right? We know from previous units how to graph or sketch a graph of a rational function. And I just want you to think back to what that process was for graphing that rational function. Think about it. Well, looking back at our previous questions here, these tables should look very familiar. In fact, these tables really helped us sketch the graph of that function. So it's actually a very similar process to sketch the graph of this as well as determine the solution of the inequality. So let's sort of do both at the same time. First step, it's already isolated, right? The fraction is already isolated. It's already one fraction. So we got to factor. So let's factor the top and the bottom. And then once you have that, you can start to sketch. So pause the video here. See if you can actually sketch it yourself. When you're done, unpause it and see if your sketch looks like mine. So I lied. Before actually showing you my full answer, I'm just going to show you what I did first. So I factored the top and the bottom. I found my two solutions, right? So 2/3 and 2. And I also found my vertical asymptotes at -1/2 and 5. So I did actually sketch those in first. So we see that there, right? The green dots represent those zeros. The red lines represent the vertical asymptotes. So the next step here, well, there's a few next steps you could do, but I'm going to create the table with those values because that's going to help me determine what's on the top, what's on the bottom, what's above the x-axis, what's below the x-axis, as well as help us solve this inequality. So pause the video here, set up your table, see if you can find your positive and negative intervals, sketch it, and also see if you can find the solutions to this problem. Okay, give it a go. So here we go. We have our table of intervals. So what this actually tells us, it tells us when x is less than negative 0.5, so when x is over here, the graph is positive. So we know it's going to be on the positive side of the graph. So we know it's going to start from this asymptote up at the top, right? And a little bit of quick algebra. I'm just going to skip the algebra on this, but feel free to check it for yourself. It approaches a horizontal asymptote of 1. Okay, so feel free to find that for yourself. But the important part here is that it's positive this whole way. It never crosses this x-axis, right? Then the next part, between negative 0.5 and 0.67, it's going to be negative, right? So that means it approaches the other side of the asymptote from below, because it has to be negative, right? And then when it gets to that point, it reaches 0, because it has to go through that point. Then between 0.67 and 2, it's got to be positive, right? So it comes above the axis just for that little piece, right? Just that little piece above the axis like that. And then between 2 and 5, it goes negative again. So it's going to go down towards that asymptote, right? Let me put the arrows here. And lastly, greater than 5, it is positive, right? So it's gonna, that means it's gotta be up here, right? Approaching the asymptote here. And again, it approaches a horizontal asymptote of 1. I'm not really worried about that for this problem, but the important thing is that it's positive for this whole region. So there's our graph. There's our quick sketch. And this process was a similar thing to solving the inequality. So now let's actually solve that inequality. It's asking where this function is greater or equal to 0. And we can see from our graph right away, where is this function greater or equal to 0? And we can see that it's going to happen over here, right? Over here, it's definitely greater than or equal to 0. It's going to happen between these 2 points here for just this tiny little region. And then it's also going to happen over here when x is greater than 5. So those are our 3 regions that basically satisfy our solution. And we see that very clearly from our table of values as well, that basically the 3 solutions are here, here, and here, right? So the one last thing to be careful about when we're stating our answer is those little signs, less than or equal to or less than, right? Or greater than or whatever it is. So let's start off by writing out this answer in set notation. X is an element of real numbers. If we want to do this super formally, x is an element of real numbers such that the first range that's true is x is less than negative 0.5. Our next range is between 0.67 and 2. And our last range is x is greater than 5. So before we finish, do we put equal signs in with any of those? Well, think about which ones are asymptotes and which ones are just zeros, right? Our zeros, if you go back to the question, actually ended up being 0.67 and 2. These are actually zeros. The function is undefined at negative 0.5 and 5. So when we're thinking about where to put in those equal signs, it's going to be with the 0.67 and the 2, right? So it's going to be there and there. So there we go. That is our final solution to this problem.